So my name is Andres. I'm the CEO of a company called Slash. You can find us on Slash.co. We are a startup builder, so we build and invest in our own startups. We try to build 4 startups a year, and we try to finance them and commercialize them. We are based out, we have a head office in Singapore. We have an engineering office of about 20 people in Phnom Penh, and we're now building an office in Bali. Claim to be experts. Yeah? None of us have a PhD in machine learning. None of us have a PhD.
That would be probably for half the audience here. That's when we actually go into some, we won't go into too much code because we are too many people to go into code, but we'll go into a little bit of technicality. And that's where for non-developers it might be a little bit difficult, but if you are open-minded and interested, you will learn a lot. Yeah? And we're hoping to get feedback from you on how this presentation goes. So maybe we can run a second one or third one that is more tailored to specific audiences. For instance, we can do a hands-on workshop for people who are more technical. We can do more a business workshop for decision makers. We can go into data science. We can do different topics, okay? Now, before I start, let us say that we don't claim to be experts, yeah? None of us have a PhD in machine learning. None of us have a PhD in mathematics. We consider ourselves just people like you, like all of us here in the room. We are street smart, we're hackers, we're entrepreneurs, we figure things out. And we set ourselves the goal this year to figure this out. And I think we weren't sure if we could. I think the answer that we came up with is I think we succeeded somehow. And we think that we can share our learning journey with you. That's the spirit in which we approach this now tonight. And I think if we can, you can as well. And I think next year we want to learn even more. We have a lot of ambitious goals on that. And maybe some of you want to join us with that through the community feeling, through community initiatives or other things. Okay? So now let me get started. I'll say a few introductory words on this initiative. So we go to the next slide. So we'll talk about artificial intelligence introduction, machine learning and neural networks, which is already a bit more technical. And then we'll talk, the second part will be about building your first machine learning application. Okay, next. Now, who am I? What are we doing here? So my name is Andres. I'm the CEO of a company called Slash. You can find us on Slash.co. We are a startup builder, so we build and invest in our own startups. We try to build 4 startups a year, and we try to finance them and commercialize them. We are based out, we have a head office in Singapore. We have an engineering office with about 20 people in Phnom Penh, and we're now building an office in Bali, a product engineering office. We also do, besides that, software development, so we work with some clients. We don't really have clients in Cambodia. We focus on global clients. We focus on global problems, yeah? Enterprise problems, mostly B2B, and a little bit more back-end algorithmic problems. Yeah? Why are we doing this? We decided that it would be great to start training more people in the community. So we decided to launch an initiative called Startup Jungel. Jungle as in getting survival skills for the jungle of life, the jungle of startups. That means getting both product skills, technical skills, and business skills. And we think there's a lot of great companies here in Cambodia or in Phnom Penh that have skills that can share with the community, and they can maybe do that for free. And we want to just launch this initiative. We don't want to own it as Slash, we don't care about that. We just want to help the community. So we're leading the way now, we're sponsoring this tonight, and we have been in discussion with about 10, 20 companies now that are interested in maybe joining. If about 20 companies each contribute 1 or 2 trainings a year, we have a training every single week like this. Yeah? So that's the mission we set ourselves for this initiative. This is an invitation for any of you to contact us and to try and join this. Get your company to approach us and talk about how this may work. We're setting up the platform and the community, and then we can have lots of fun and learn a lot. Okay? So next, I'll go next. So let's talk about AI. Yeah? I speak quite fast, so if you think that I'm speaking too fast in English, give me a sign. You can just do this, like slow the hell down. Yeah, so that's slowing down, and then I'll try and slow down, okay? So let me give you a very high-level, grandmother-style introduction into AI, okay? So AI, if there's one thing you need to walk away from in this room, is that AI is the new electricity, yeah? Artificial intelligence will be everywhere very, very soon, like electricity is everywhere, okay? It will become a utility, like electricity. It will power everything. Electricity powers now the lights, it powers our houses, it powers our factories, it powers everything. AI soon will be a layer on top of that, powered by things like electricity, but will be intelligent, yeah? It will be a computational layer on top of that that will make everything, quote unquote, intelligent, okay? That's the main message. If you have that, you can walk away, yeah? This is the kind of the main message for tonight, yeah? So we'll go to the next slide. Now, a bit of background. I don't think every one of you realizes that the world was a very different place about 250 years ago. About 250 years ago, there was what's called the first industrial revolution. The first industrial revolution happened in Europe, and it was a revolution where all of a sudden they figured out they could make power by putting water and heating water and creating steam. And with that they created steam power. Yeah? This was a revolution because before that, to generate power through a machine of sorts. This was the first industrial revolution. This created, in effect, a revolution in what we could do with human power. Yeah? It is generating eventually factories. Next. The second industrial revolution, which was around 1900s, between 1870 and 1910, is a revolution where, well, actually, if you go back to the previous slide, it's an important point to mention. The first industrial revolution around 1780, yeah, and it took a while for this to ramp up and for people to start using it for applications like textile, yeah, factories. So the second revolution, here's a number 1913, but actually the electricity was around 1870, about 40 years before this. Yeah? This gives you an idea of how long it took to go from electricity to creating applications for electricity. Okay? And then the applications became all of a sudden creating of, we took this artificial power and we figured out how to store this power. Yeah? We stored it. We generated it somewhere, we stored it, and then we transported that power to somewhere else. And all of a sudden, we could generate power one place and use it somewhere else. So this, oh, what happened? Okay, so this allowed us to create factories and cities that are bigger because we could generate it one place, transport and move it somewhere else. Yeah, this allowed us to create, amongst other things, mass production, mass transportation, all those things that were used, including cars, including large factories that were needed for creating of the first cars. All of that was done around that time. It also included TV and radio. Yeah. So the third industrial revolution happened around the 60s. Okay, so again, 50 years later, give or take in terms of applications, all of a sudden we were starting to look at electronics. Now the first electronics were already invented during World War II. They were inventing big computers and stuff. But they were like the size of a house, and and they were trying to figure out with tapes and wires to do something with it. In the 60s, circuit boards were created that were smaller and smaller. Intel, you all know Intel probably. The first chip of Intel was in 1971. It's not that long ago, it's about 60 years ago, yeah, 55 years ago. So all of a sudden what they did is, with all this computational power, they start putting circuit boards together, and we invented essentially what is modern electronics. Modern electronics gave us, after some time, gave us the consumer internet, what everyone knows as the internet now, right? DARPA, invented this around the 60s, like 65 or so. But it was only around 1985 or so that internet was coming out more and more, and around 1995, so about 20 years ago, the first browsers came out. And I remember, so I'm a bit older than probably some of you in the room, but I remember when I was on the internet in '94, there was nothing on the internet. It's not like I could do and I could read news. I mean, I could read a bit of news, but that was about it. And then around 96, 97, there started to be like chat rooms and stuff like that. But it was all very, very slow. Yeah, this is all very, very recent. All these things. Yeah. So that's the third industrial revolution. Okay. So now, all of this went from artificial power, which created all these layers of applications, and now we're going to artificial intelligence. Okay? Because we have the foundational power, and we have computerized, and we're digitizing the world. We're putting now sensors everywhere, and we're connecting those sensors through the network of internet, whether it's a closed or an open network. And all of a sudden, we're creating algorithms on top of that. And those algorithms, in effect, make everything we touch more intelligent. Yeah? So this is the revolution that is happening right now. Now, again, this is not something that is happening like, you know, the 15th of October 2017. No, this is a process of probably 20 to 40 years or more where an entire generation of new changes will be coming up. And they will be global. Yeah? Electricity came to Cambodia, right? Electronics came to Cambodia. AI is coming to Cambodia, right? Whether you want it or not, it's coming. And it's going to come quick. Because unlike electronics, which took probably about 40 years, and internet, which took about 20 years, the time to move things to the market is going faster and faster and faster. Yeah? Facebook is only 12, 13 years old. Yeah? GitHub, which a lot of you guys are using, is from 2007 or so. That's about 10 years old. iPhone is about 10 years old. All those things are getting really, really quick out of the market. Snapchat, which you probably, a lot of you have heard of, Snapchat is only about 4 years old or something, right? Uber is only around 6 years old. So those things are moving really, really quick. Instead of being 40 years like before, it would probably be more like 10 years or even less, right? So you're sitting in a room now getting introduction on AI, but in a few years from now, you'll consider, yeah, of course, this is normal. This was always like this. The reality is that it was not, yeah? And it will go really quick. This is both an opportunity and a threat for a country like Cambodia, because there's only 10% or so of the population here that has higher education. Guess what will happen with AI, right? A lot of those jobs will be automated eventually away. So it's a societal problem as well. Right? It's not just about how can we build a better Uber for tuk-tuks. It's also about what does this mean for our society. Yeah? Next. So okay, so what is this? Oh, this was the kind of the inspiring speech. Now let's go to practical stuff. What is AI? Yeah. Now, at a very high level, AI is about taking some kind of input. I don't know if you can see this with the light. Some kind of input. That input is data. Yeah. That input can be sensors. It can be images. It can be emails. It can be anything. Then having some program, some artificial intelligence that will do something, and then will give you an output. That is at a very high level. Now you will tell me, isn't that what software already does? Yes, that's fairly true. And we'll talk about the difference between what you would probably consider your traditional software programming skills and what we consider AI. Yeah? But that is the high level definition. You take an input, you do something with it, you get an output, and that something is done through an AI. Yeah? So there's two types of AI. There's weak AI and there's strong AI. Weak AI are AIs that are focused on very specific applications. For example, filtering spam in your email. Yeah? Or recognizing pictures of cats and dogs. Yeah? They're focused on one specific application, they're really good at it. For example, also the AIs that were beating the chess players. Okay? Then there's a second type of AI, which is a strong AI. Strong AI is essentially super intelligence. It's like a human. It can think not only about classifying cats and dogs, but it can also think about creating Khmer art. Died again? Okay. It can also creating Khmer art. It can also think about being a dentist. It can think about anything. Yeah? In other words, it has a general ability to think and to do things with that. Maybe someone can check on the microphone if there's a way of stabilizing this. I speak loud, but I don't know if I speak loud enough. Yeah? Is it good there in the back? Can you hear me? Yeah? Okay. For one function. It can do multiple things really good. Okay? So the 99% of all the AI applications you will hear, maybe someone can fix this. It's like, okay, I'll put this here. In the meantime, I'll be loud. Yeah? Okay, is it stable? Okay, so 99% of everything you will ever hear about AI in the next 5 years, most likely, or 10 years, is weak AI. Everything we're going to talk about today is weak AI. That means we optimize for one function. Okay? Strong AI at the bottom, that is where you need a PhD. Yeah? That's not us. And there's probably about 1,000 people in the world that are working on those things. And they're in universities. They are hired by Google, by Microsoft, by Amazon, by Tencent, by Baidu, by Alibaba. Those are the guys that are very advanced in what they're doing. They don't have an immediate application. They're just trying to build things that can outsmart humans. And you know what? That might take 10, 20, 30, 40 years, right? Now there's different, I can talk a little bit during break if anyone is interested in this. There's different predictions of how quick this will go. And some are ranging between 20 years, some are ranging between 80 years, yeah? Thanks so much, man. So there's probably between 20 to 80 years, yeah? Depending on what it is and what we mean with outperforming humans, and maybe it's in beginning like 5 functions, 10 functions, 100 functions, maybe not 10,000 functions, yeah? But so there's now more and more people doing this. The most famous company probably doing this is some company called DeepMind. They were bought by Google, and they're creating general intelligence. That's their focus, okay? So the general intelligence, the strong AI is the stuff of science fiction currently, yeah? Let's go to the next one. So we're focusing on this. Okay, I don't know if this is readable. It's a bit small. So I'll answer my own question, which is, how is AI different than traditional software development? Okay, so at the top, if you can read this, this is called traditional programming. This is what 99% of the developers in this room are currently doing, most likely, right? What that means is that you have data, you have a program you write, you know the rules of that program, and you as a developer understand what those rules are, and you're programming it in. Then you take those rules, you throw that into some kind of application or computer, and then you get your outputs, okay? That is the majority of applications right now, yeah? And we call those expert systems. We call those expert systems, okay? Because those systems are an expert, for example, in Excel, or they're an expert in accounting, or like Uber is an expert in getting you a taxi, or PassApp here, an expert in getting a tuk-tuk. So this is an expert system, yeah? The second part is what we're going to talk about today. This is machine learning. The big difference here is that as a developer of a machine learning application, I don't know the answer. I don't know how my application will solve the problem. I know there's a problem, and I feed that application with data, but I don't know the answer. In other words, I can't program the rules in, or the code, or the logic, because I don't know it, right? If I want to classify cats and dogs, and I want to have a 99% chance of classifying it correctly, how do I program that? I have no idea, right? So that's where machine learning comes in. And we'll talk about how that works, yeah? Then this third one, this is the future AI. There's already a lot of research on this being done, especially by military services, like Pentagon is doing a lot of research on this. And what that third one is that not only you give an AI a goal, and the AI optimizes for that goal, regardless of what it takes, right? So the AI will figure out the answer, will figure out what data it needs, and it will get the job done, yeah? And not only that, but the AI will be able to explain you how it got the job done. So in other words, it will become an expert and tell you how it became an expert, and it will actually be an expert, right? So that's the third type. And there's a lot more research being done there. It's scary, but it's also quite interesting what's being done there. So I'll go over each one a little bit more. So wave one AI, it's basically non-AI. I would call it non-AI, but it's the wave one. This has been going on since the beginning of programming, yeah? And especially around the 70s and 80s, so about 30, 40 years ago, when we went up the programming languages, we went to very low-level programming language. Then we started going to like second, third generation, fourth generation of languages. We started creating better and better frameworks for programming. When I started programming, I did initially physics, and when I started programming Java and HTML and those things, a lot of things didn't exist. Like we had very limited frameworks. So we had to build everything from scratch, right? There were no such thing as APIs, they were called SOA. But like all these things were not there. So it was still very basic. Yeah. When I see sometimes how the team is programming, I'm like, my God, you're cheating. You're just using a library for this. we had to code it ourselves, right? So now there's so many things that you can create an API for, take a library, get open source communities from it. You just plug and play, you put it together, you make sure your architecture makes sense, you stabilize, you have DevOps, bam, you deploy it and it all works well. And you have shared servers with AWS and all these things, you can scale it, right? the world has become so much more complex, so it's not cheating. You need it because the expectation is that you can build an app in a hackathon for 48 hours. Whereas the expectation when we started building things, there were no mobile apps at the time, we needed like 3-4 months, right? Now the expectation is that you can do something in 48 hours. So you need all those libraries, and you need to become a magician at combining those. So, but when it started out, expert systems started out as these foundational things, right? And all those things started out small. So there's expert systems to do loading of ships in containers, there's expert system for chess, there's expert system for accounting, for example, right? The big disadvantage of those systems is that they're very focused and they have no learning capability. They are what you program them for. That means if you program them one way and then you leave them there for 5 years, after 5 years they will be exactly the same programs they were, when they started, right? In other words, they're really bad for the real world. Meaning, accounting is great and it will work, but if the rules of accounting change in Cambodia, your system will have to be updated, right? So let's go to the next one. So this became very apparent in 2004. 2004, DARPA, which is the defense agency of Pentagon, they invented the internet, actually, as a matter of fact, in the 60s. So DARPA put a challenge out there in the United States for all these smart people. The challenge was, we want you to drive through the desert for a certain distance. I think it was 10 kilometers or something. We want you to drive autonomously without a driver. Yeah? And we'll give you a prize if you succeed. Right? So there were quite a few teams. I think it was around 15 or 20 teams that participated at this challenge in the desert. They were driving. Guess what? 0 succeeded. Right? Then they realized that their expert systems could not code every single rule in the world. It was impossible, right? There was not enough time to code it. Plus, the conceptually, developers could not think of every single rule, right? It's too difficult. That's not the real world. The real world is messy and complex and chaotic. So what they then did is in 2005, some of those teams started applying new technology, machine learning, it's called, right? Machine learning at the time was an obscure department of universities where there's some geeks, professors, like tinkering with it and trying to figure out how to make this work, right? It had no commercial application, or very little. So, and I'm simplifying a little bit, yeah, but so what they then did is they said, okay, well, we can maybe apply this to a real world problem. And guess what? 5 teams succeeded, yeah? It's not just because of machine learning, it's also because they had better sensors and other things, yeah? But machine learning was an element of it, okay? So this gave rise to wave 2. Kevin, we'll go to the wave 2. So machine learning, yeah? So like I said, the majority of applications when you hear about AI is this, yeah? Everything you hear is hot is this, right now, more or less everything, yeah? So that's the hyped up applications, right? In 2017, you will hear more and more and more about it. In the next 3-4 years, this will explode, yeah? Now, you need an input, you want a response. A to B, that's what you want to create, okay? So the input can be email, the response can be, is it spam, yes or no? The input can be image, the response is, what is the object, cat or dog? The input can be, what is the audio? The response is, give me the text of the audio. For example, my speech, if you apply an AI on it, maybe they can write down, extract the text of what I wrote, of what I said, yeah? English, Khmer would be another example. Text, audio, the other way around, yeah, etc. You can think of pretty much any inputs, you need a response. You want to create something in the middle that does that generates that response. Yeah, that's machine learning. And it gets complicated, but that's the 50,000 feet view, yeah. So the great thing is that it's statistical, so you can have a prediction of how accurate your model is. For example, we're going to show you some examples of showing images, and we want to show whether it's a cat or dog. We can show whether it's 95% going to be accurate or not, based on our data, yeah? That's so statistical. The other thing is that you can supervise the learning, you can optimize it. So it's, there's a methodology, there's a process for developers and scientists to figure out how to improve it over time, yeah? The bad thing is that it needs a lot of data, yeah? There's a saying that data is a new oil. That's the saying, yeah? Data is a new oil because data becomes very valuable. That's why Google and those guys are giving all their things for free. Because they don't make money on you paying to get access to it. They make money on you using it so they can generate data and they can use that data for other things. Yeah? That's the business model of the future if you can get it done. And there's ways of getting less data, and we'll talk a little bit about this, I think. The other disadvantage is that it has very limited ways of understanding the context. So it can say that an image is a cat, but it can't explain you why it's a cat. It's just statistics. Yeah. So as a developer, you can't extract the rules out of that. Yeah. So even if you were to be able to decipher some kind of ancient Khmer script in Angkor Wat, you may still not know the rules of how he deciphered it. Yeah. Next. So that brings us to wave 3. So wave 3 is, and as the last few slides, these type of AIs are optimized for a goal. Yeah. And what they do is that they create an explanation of how they achieve that goal, which allows us to understand why the AI does something, which is very, very useful. Because you want to know if it's 95% accurate, some kind of machine learning, you want to know what is the 5%, right? I mean, especially if it's about life and death. Think of Tesla doing self-driving cars, right? You're driving a car, and then Elon Musk stands here and says, yeah, it's 99% accurate. And then you kind of raise your hand, so what's the 1%, right? Am I gonna hit a few people and kill them? Right? You want to know that, right? So that's where these explanation models can become useful, okay? Now, the other thing is that you can see those AIs with less data. So you can create, with less data, you can get them started. It's like a baby. A human baby learns by doing things. And he learns with very little data. I have a son of 14 months. I see him evolve. He learns with very little data. I show him something once or twice, and he gets it, and he does it. I'm amazed. Yesterday he was trying to plug the thing out of the wall. I never showed him that. Maybe he observed it once from me, and now he was trying to pull the electricity plug in the wall. It's like, wow, how did he learn that, right? So it goes really quick. Somehow the human brain has an extremely advanced machine learning algorithm. Yeah? Next. So for example, this is a cat. Why? Well, we as humans would know the answer. But here the model would say it has fur, it has whiskers, it has claws. Those are the features. Yeah? So this AI would explain you why it is a cat. Okay? Next. So these are 3 waves. Traditional programming, which is not really AI, but that's what all of us are doing in terms of traditional software. Then it's about machine learning, which is using data and using machine learning algorithms to get an answer, yeah, to get a prediction, an accurate answer. And the third one is goal-based AI. We give them a goal, they will figure it out, and they will tell you how they figured it out. Okay? So I'll finish with this slide on my introduction. So the future, there's a whole topic about future which we can talk in a separate presentation. But it does mean that AI will get better and better at doing our jobs. Yeah? So it does mean that it poses some questions about what we will do as jobs. For example, I think simple programming will be more and more done by AIs. AI will generate simple code. Yeah? Not yet, not in the coming 2-3 years, but within 5 or 10 years that will exactly happen, right? So we as humans will have to upgrade ourselves. We'll have to become better and better and better. Similar to my example of like the libraries. We had to code when I started out about 15 years ago. We had to code everything ourselves. Now you use libraries, right? So similar here, you will have to start using tools, AI-powered tools, and get better and better and better. Yeah? So AI will enhance us, but it will put us some big questions about how society will evolve. Yeah? So that's a topic for another evening. So, okay, we reached the end of the general introduction, which hopefully was simple enough as a general introduction for everyone to understand. We will go now one step more technical. So we'll have 4 speakers, okay? So Kevin will give us introduction. Kevin is leading our AI efforts in our office in Slash here in Cambodia. So he's the right guy to talk to if you want to talk about anything AI or anything we're doing. We're also hiring, by the way, just saying. But we are looking for, so he will explain a little bit more about machine learning and neural networks, right? And then we'll have a short break. Over beer, talk to people who are interested, exchange business cards, whatever, okay? So we'll get on with it. So especially for the break, I'll request to just keep it really focused and come back. Thank you so much. I'll pass on to Kevin. Yeah?